Hey guys, welcome to DSA-n-Design. Today we will look at another problem in array, which is reverse an array. Alright, so let's try to understand what exactly we want to do as part of reverse an array, right? So let's say we have an array, elements are 1, 2, 3, 4, 5, and as part of reversal, I should be actually getting 5, 4, 3, 2, 1. Basically, the last element should be coming at the first and kind of its reverse order, right? And the first element should be going at the last position of the array, right? So let's try to understand what should be the logic, right? What should be the approach basically, okay? So for example, let's try to put the index for this. So this is 0, 1, 2, 3, and 4. All right. So basically, there are 5 elements, and the index is starting from 0 to 4, right? N minus 1, 0 to n minus 1. All right. Now, what exactly we can do there? So if you think generally, right, we can actually do one thing, right? We can actually take an additional array. Okay, we can declare the same size of array, and then we can read the kind of array from the reverse side. Okay, we can run a for loop and we can read from the reverse side and keep storing in the answer array basically, right? And then finally you display um, the output, right? So this is one of the approach, kind of one of the approach. But in this case, the challenge is we don't want to take any additional space, right? So the condition here is basically the space complexity, right? For this should be order of 1, which means we should not take any additional array as part of answer. Okay, so that is the condition. So obviously we cannot take any extra array the to store the data. All right. So what exactly we have to do? We have to do the in place kind of swap, right? So if you need to do the swap between this first element with the last element, and similarly like this, we have to basically think something else, right? And that's where we get uh, we have the concept of two pointer. All right. So two pointer, let's see how it works basically, right? So let's try to take this, say, very same example. All right. One second, guys. Let me see why this. No idea what is this. Okay. Okay. So for example, um, let's try to, yeah, let's try to take the same example, right? Okay. So for example, uh, okay, this is the one, right? Let's say I put one pointer here, let's say P1 pointer, and I put another pointer here. Okay. Can I simply swipe this with this, right? So if I swipe P2 with P1, right? And then my job is done. For example, let's say in the first case, I am swiping P2. P2 will be basically, okay. Let's do one thing, guys. I think it's better to take here down, right? So 1, 2, 3, 4, and 5. Okay. Let me take different colors so we can take it clearly. Okay. Okay. I'll take this color. Now, for example, let's say this is my P1 and this is my P2. All right. Now, what I say is I will actually swipe it first, P1 with P2. Now, what will happen is uh, uh, P1 with P2. So, what will be resultant array? With this will be 5, 2, 3. There is no change in the middle one. It will be just the last and first element will be swiped, right? And then after this, what I have to do is I have to move my P1 to right hand side basically, P plus plus, okay? So my P1 will be moved here, P2 will be here because we are able to sort out the first and last element, right? Now P2 will be P2 minus minus, okay? Which means P2 will be coming left hand side, okay? And right hand P1 will be actually moving right hand side in every iteration, okay? Now again swipe these two, okay? So this will be 5 and then this will be actually this will be swiped, so it will be 4, 3 will be as it is, and 2 and 1. All right. Now what will happen is uh, now P1 will be actually moving this side, then the P1 will be here, and P2 was here, right? Here basically it will also be coming to here. All right. The moment it is actually uh, coming here, right, we should stop actually. Now you see this array is reversed array, isn't it? Correct? Rather, we can actually stop our P1 the moment P1 become greater than or equal to P2, right? That's where we can stop it, right? I think this is the logic basically, right? So let's try to do one thing. Let's try to go to IntelliJ and try to code this basically, how we can do this, right? So I hope that you got the idea, right? We have to take two pointer and yeah. So let me just create a class. I will say reverse array. All right, guys. So let's take main method and I will just take simple array 1, 2, 3, 4, 5, maybe 6 also. Okay, 6 elements. Now, what I said is I have to basically take two pointer. One should be actually pointing to this one. So what is the location for this? Let's say int p1 should be at 0. Okay, and okay, first of all, let me take int int n, the length of the array first I will take, okay, so that I know exactly how many. So this will give me the length, okay, but my p2 should be what, guys? Int p2, my P2 should be n minus 1. Agree? Because my P2 should be y n minus 1 because my last index of the this particular array is n minus 1 only, right? Because it is one lesser than that, right? So here 6 element, then last element. So actually first pointer should be the first pointer, P1 should be pointing to this one and Pt should be pointing to the last element. Okay. Now, as I said, what I'm going to do is I'm just going to say P1 while I will run this for loop until P1 is less than P2. Okay, the moment it become equal to, I will stop it actually. Okay, so until this P1 is less than P2, I will continue to swipe. So how I can do swiping? It's very simple, right? I'll take one temp variable, okay, and that's where I will store P1, okay, and one second, I'll be storing this, and then array of P1 should be storing array of P2, okay. Now array of P2 should be storing what? Should be storing temp. All right. This is what the swiping logic. Now, as I also said that I will continue to actually move. P2 should be continue to move right hand side and P1 should be left hand side. So what I have to say P1 plus plus right hand side and P2 should be minus minus left hand side. It should be shifting. Okay. That's all, guys. This is all we are done basically, right? Now let me try to actually print before swiping. So this is the swiping logic. Here only I will try to print actually, okay? So let me try to print, okay? I'll say uh, original array, okay? Original array, okay? And then I will print here down. I'll just take a for loop, okay? This is just for printing, okay? So I equal to 0, I is less than n, and I plus plus. All right. Now, if I just say print it basically, okay, what I will do is array of p1, oh sorry, I, right? This is all. I will just give some space so we can read it nicely. All right, this is done. And similar way, I will actually print same code. I will print after swiping. So this is my swiping logic. Now I'll put here so that I can actually say reverse, 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 reversed array. Okay. All right, guys, let's try to see and run, okay, whether this logic is working or not, okay? Let's try to see. Wow, fantastic. Okay, so this is just, okay, I can just say one thing here, just to show you in a nice way. I can just say here, mm, 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 maybe I will just put one here as well, okay, so that you know I can see it in proper line. Oh, one second, okay. Extra means new line basically, right? So that you can see the proper print. All right, guys. Look, original array 1, 2, 3, 4, 5, 6, and reversed array 6, 5, 4, 3, 2, 1. Okay. Now, so this is how basically is the logic. Now let's come back here, right? Now, if you look at here, right, printing part, forget about printing part. I am not bothered about printing part, right? So can you tell me what is the time complexity and space complexity in this one, right? So obviously we are not taking any extra space. First simple one, right? So we are not taking any extra space here. Like we are not actually taking any array to store the data. We are actually doing in place, right? We are actually using the swipe. That's why the time space complexity is basically order of one, okay? And then time complexity, guys, time complexity, let's try to see. So this is my printing part. I'm not really bothered about this printing part, okay? Because printing part is something just to show it, okay? So uh, this is um, this is the only loop which is actually taking time. And what we are doing here is basically we are actually traversing entire array, right? We are actually taking pointer from left and pointer from right, and we are traversing the entire array. That's why the time complexity is going to be order of n basically. Okay, so that's what basically we can conclude here. This is the kind of the time complexity. Okay, 1 second. All right, guys. So for this, right, space complexity is order of 1 and time complexity is order of n because we are traversing all the element in the while loop. All right. Okay. So this is what basically I'm telling you. This is the kind of optimized approach. Okay. And yeah, so that's all for this video, and I hope that this video, I think if you like this video, I will kind of request you to subscribe, share with your friends, and to give your love you can like my video and also comment if you want me to do, if you want me to make a video on any other topic. But we are currently actually learning array series, and we will continue to do more and more such kind of problem statement. We will be solving them, and you make sure that you not miss any videos, so you can actually hit the bell notification as well, so that you get a video as soon as I upload them. All right, guys. So thank you for watching, and see you soon with the next video. Bye.